Oftentimes, we may have to split a large combinatorial problem into several smaller combinatorial problems. Let me show you what I mean. You're the CEO of a small corporation that has 5 engineers, 7 lawyers, and 8 accountants. And you want to make a group of 6 that consists of exactly 2 engineers and 4 lawyers. How many such groups of 6 exist? So the first step to this problem is to recognize that order does not matter, meaning that we're going to use combinations instead of permutations. The second step is realizing it's going to be difficult to solve this problem in one shot. For example, the answer is not simply 12 coming from 5 plus 7, choose 6. Because 12 choose 6 implies that we are choosing a group of 6 among these 12 people, but this group of 6 may have more than 2 engineers or less than 2 engineers, or conversely, it may have more than 4 lawyers or less than 4 lawyers. So 12 choose 6 does choose 6 people, but it may not necessarily be the people that we need. So how can we ensure that we have exactly 2 engineers and exactly 4 lawyers? And this is where we split these combinatorial problems into smaller ones. How many ways can we choose 2 engineers from 5 engineers? Well, notice how I said the word choose. So 5 choose 2 times how many ways can we choose 4 engineers from 7 lawyers? That's 7 choose 4. So the total number of ways that we can make a group of 6 that consists exactly of 2 engineers and 4 lawyers is 5 choose 2 times 7 choose 4. So you may be wondering, why did we multiply? Why couldn't we have just added them? And we'll try to explain that with an example. Let's say we were only trying to choose 1 engineer and 1 lawyer. How many ways? If we were to multiply, that would be a total of 5 choose 1. And this is the correct way. Times, sorry, my stylus is going wacky. 5 choose 1 times 7 choose 1, which is equal to 35. And you can imagine, say we have our 5 engineers here and our 7 lawyers. 1, 2, 3, 4, 5, 6, 7. How each engineer can be paired with 7 lawyers. And since we have 5 engineers, we have a total of 35 such pairing. If we were to add, that would be 5 plus 7, 7, which results in 12, which is clearly not correct. Multiplying refers to and, so we're choosing, in this example, 2 engineers and 4 engineers. If we say wanted to change this question so that it were choosing 2 engineers or 4 lawyers, then it would be correct to add. But here, since we're doing and, we multiply and we split our large combinatorial problem into a smaller one. And it works. Let's try this problem. How many ways can we make a group of 5 from among 12 people if there is exactly 1 leader and 1 co-leader, and then 3 normal participants? If we were to do 12 choose 5, our answer would overcount our sample. 12 choose 5 implies that we can have 5 participants, or only 4 participants, or we may have 5 leaders. If we would overcount what we're looking for. So if 12 choose 5 would not be correct. Instead, we can split this large problem into smaller combinatorial ones. How many ways are there to choose 1 leader from among 12 people? Well, that's 12 choose 1. Alright, now how many ways are there to choose 1 co-leader? Since we already have 1 leader, and a leader can't be a co-leader at the same time, that means we now have 11 people left. So now we have 11 choose 1. How many ways can we have 3 participants? Well, we already have a leader and a co-leader, so that leaves 10 people left, and 3 participants, so we have 10 choose 3. We're using combinations because permutations is not required here. So there are a total of 12 times 11 times 10 times 9 times 8. Divide by 6 ways we can choose a group of 5 that consists of 1 leader and 1 co-leader and 3 participants. Let's say instead of having 1 leader, we have 2 co-leaders and 3 participants. How will this problem change? Well, Since there are 2 co-leaders, if we start, let's just calculate co-leaders first. There are 12 people choosing 2 co-leaders. It would be 12 choose 2. And now that we have 2 people chosen as co-leaders, there are 10 people left who can become potential participants, and we're choosing 3. So if we have 2 co-leaders and 3 participants, we have 12 choose 2 times 10 choose 3, which is 2 times less than having 1 leader and 1 co-leader and the 3 participants. Thank you for watching.